Alright, we're going to do an example here in the textbook. It's going to be on page 121, example 3.12, and basically what it's doing is just asking you to find V out using nodal analysis. Alright, so let's get started. First thing you want to do is observe the circuit here in the figure and see that there are 1, 2, 3, and a big ground node. That's 4 nodes. Go ahead and label those. We want to set one of those to ground as our reference node. And we're going to do this guy 0 volts. And according to the method for nodal, we know that there will be the amount of nodes minus 1. So what's that? 4 minus 1. 3 linear equations, independent equations, needed to solve for all the nodal voltages. That's not too bad. We got a label. Let's do some current labeling. We'll call this one I1, I2, I3. It doesn't matter which way you, guess the current's flowing, as long as you abide by the passive sign convention. So basically it's just saying, it flowed from high to low. Basically it's going to work out in the end that if you're wrong, assumed wrong, it's going to be negative, so it works out. It's nice like that. Let's start by looking at this supernode. We need to get an equation for this here, and we do that by observing that there's E2 and this is supplying voltage, so we can say E2 plus this voltage equals this voltage here. In other words, E1 equals 4K times IX plus E2. Alright, so we have the nodal voltage there. Now let's do KCL at that node. KCL. Alright, we know that's in is going to equal to out, or in minus out equals 0, so on and so forth. Let's observe, we have 8 milliamps going in. We also have IX going in. Once again, it's this node here. This node. We have I1, I2 coming out, and 2 milliamps coming out. So, let's set that up. We got 8 milliamps plus IX equals I1 plus I2 plus 2 milliamps. Alright, so there's one equation. There's another equation. We need one more equation. Let's look at E3. E3 KCL. Alright, change the color up a little bit. Don't want to bore you guys. Alright, right off the bat, what can you say about V out? V out, the drop against this resistor, is actually going to be equal to the voltage drop across the resistor, I3 times 1K, or E3 minus 0 over 1K. So that's something we can use to relate. Equals E3 equals I3 times 1K. But that's not our KCL. Sorry for doing that right now, but we're going to use that later. Alright, so KCL. We have in equals out. We have 1 going in, 2 coming out. So let's do 2 milliamps equals an IX plus an I3. Alright, and like I said, we only need 3 linear independent equations in order to solve this. Let's put this into AX equals B matrix form. And we're going to use E1, E2, E3. So it's a little sloppy. And we get these values all in there by setting up this system of equations. So look, we have our 3 equations. 1, 2, 3. Now let's use what we see about the circuit, what we, what's given to us from this circuit about IX, I1, I2, I3, and put them into terms of E1. Sorry, all these here. All of them right there. Alright. So let's do that this way. Over here, change color, sorry. We have E1. I'm going to use this equation here first. This guy. And we have, like I said, E1 is going to be equal to... Well, first we have to actually find something for Ix. Alright, so we don't want to use this equation itself and put it in terms of Ix. We actually want to use, we have another one here. This guy right here. Let's write it over on the side. Here. Alright, Ix equals E3, or current flowing from high to low, E3 minus E2 all over the resistance 2K. Alright, let's use this to get rid of our Ix. I mean, while we're at it, let's find our I1, I2, I3. I1 is E1 minus 0 over 3K. So right there, E1 over 3K. I2, same thing, what's that? E2 over 6K. And I3, we set up here, E3 over 1K. So, E3 over 1K. Bam. We have everything we can put into terms of E1, E2, E3 in order to fill out this A matrix down here. Alright, let's get started. So for our first one, substituting what we know about Ix, we will end up getting, what's that? Let's say E2 plus 4K, whatever Ix is, which would be E3 minus E2 over 2K equals E1. Alright. I'm going to set that up so it's in terms of just E1, E2, E3, and equal to some constant. And we see that ends up being minus 1 E1 plus a minus 1 E2 plus 2 E3s. And that ends up all equaling 0. In other words, it'll look something like this. E1 comes over, we get a negative E1. This cancels out, we get just 2, so we have 2E3 equals, and what about E2? So 2E2 is a minus 2E2 plus a 1, we get a minus 1E2 plus 2E2, and that's all equal to 0. So then we fill that out with its coefficients, this -1, -1, 2, and put them into the system here. Equal to 0. Let's do the same thing for our two equations. Alright. Separate that, and you can see that our other equation at 8 was at KCL over here. This one we're going to work with next. So we get what? We can bring the minus 2 over. That ends up being 6. And then we have all these currents there. But we have all substitutions for those currents to get into terms of E1, E2, E3, so that's not going to be a problem. And that ends up being, I'm going to skip it just because of time. You guys are free to either ask me or work it out and see if you get the same solution. Give you a little bit of practice. We have 1 over 3 E1 plus 1 over 6 plus 1 over 2 E2 plus a minus 1/2 E3, and that is equal to, I get 6. Alright, and the reason I did this, just in case you're curious, is I basically multiply it by 1,000 or K, and it cancels out the resistance and gets rid of the milli, comes out to, 10 to the 1 order or whatever, and fill that in here. 1 over 3, this ends up being, what's that, 0.06667, and this is a negative 0.5. Alright, and then for our last guy, split that up. For our last one, let's use that E3 KCL, so we have 2 milliamps. equals whatever we know for Ix. That ends up being E3 minus E2 all over 2k plus E3 over 1k. Do the same thing with multiplying by basically both sides by 1,000. You know, this cancels out, this cancels out. This becomes just 2 amps. And fill it out here, and we get, there are no E1s. There is minus 0.5 E2s, and then there is 3/2 E3s. Sorry, I didn't fill this out up here, but this is end up 6, and this is 2. So what we can do now is head over to MATlab, and I have this set up here. This is how I like to set up my matrices in MATlab. But so what you're doing is you're filling in the rows here. These are 3 rows. Here's your B matrix, and then we're going to solve X, and I'm going to display the result there. Hopefully it comes out to be the same as what's in the textbook. So A, let's fill that in. We have minus A, comma, minus 1, comma 2. Go down to our next. We have 1/3 0.67 and a negative 0.5. Alright, what's this? We have 0, our third row, negative 0.5, and a 3 over 2. Alright, let's fill out our B. What's that? 0.62. Okay, 0.62. Alright, we go ahead. See, it's going to solve for our X matrix. It's basically going to find the values here. Whoops. Alright, so let's do that. Control Enter. Run that. Bam, we see it displays right here 6.28. Let's see, 6.28. What is that? 5.3, I think it said. Volts is what our E3 is equal to, but we set up here that E3 is actually equal to V out, so we actually get our solution right here. And what's that according to the text? Let's bring that over here. Bam, we see V out equals 6.29. I guess we just ran into 2 sig figs, but you know, we got the solution. There you go.